Now prime and composite numbers. So first we will write numbers and then factors of the number. You can see here 1. 1 is divisible only by 1, so 1 factor is there. 2 is divisible by 1 and 2. 3 is divisible by 1 and 3. 4 is divisible by 1, 2 and 4. 5 is divisible by 1, 5. And factors, all the factors of 6. 1, 2, 3 and 6. And so on you can see here. Now numbers of factor. Here is only 1. Here is 1 and 2. 1 and 2. 1, 2 and 3. Then 2. In this way we will count the factors. Now you can see some numbers are having 2 factors and some are having more than 2 factors, and only one is having only 1 factor. So we can say that 1 is neither a prime nor a composite number. And those numbers are having only 2 factors. These all are prime numbers. We called these numbers prime numbers. 2, 3, 5, 7 and 11. These are so we can say that 2, 3, 5, 7 and 11. These are prime numbers, and some numbers are having more than 2 factors. So 4, then 6, 8, 10, 12. These are composite numbers. So in short we can say that the numbers other than 1, that means 1 is neither a prime nor a composite numbers, whose only factors are 1 and the number itself. Factors are 1 and number itself. Factors are 1 and number itself are called prime numbers. Underline the definition. It's very IMP. Numbers having more than 2 factors are called composite numbers. 4, 6 composite numbers. So you will learn the definition and underline the definition. Now without actually checking the factors of a number, we can find prime numbers from 1 to 100 with an easier method. Let's see on the next page. This method is given by Greek mathematician Aristophanes in the 3rd century B.C. That means before Christ. I will send the image, the meaning of full form of this and what we call before Christ. Let us see method. List all the numbers from 1 to 100 is shown below. It's very easy. First we will write 1 to 10 numbers row wise. Then 1 is neither prime nor composite, so we cross out this number, and then encircle of 2 and multiples of 2 we will cross. Then encircle of 3, because 3 is a prime number, and then multiple of 3 we will cross out. Then 4, already multiple of 2, so already crossed out. Then 5, multiples of 5 crossed out. Then 7 until 100 we will do. So in this way, at the end the numbers are left with encircle. You can see here 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. So these numbers are called prime numbers. So the method in detail already I explained. You will make one video and you will send on my personal WhatsApp number by doing this activity. Cross out 1 because it is neither prime nor composite. And circle 2, cross out all the multiple of 2 other than 2 itself. Then encircle 3, multiples of 3 we will cross. The next 5. Continue this process till the numbers in the list are either encircled or crossed out. All the encircled numbers are prime numbers. All the crossed out numbers are composite numbers. Then one special number we will call y, because neither prime nor composite. This method is called the sieve of Aristophanes. Now try this. Observe that 2 into 3 plus 1. So 2 3s are 6. 6 plus 1, 7. And 7 is a prime number. Here 1 has been added to a multiple of 2 to get prime number. Can you find some more numbers of this type? Let's try. Next number, if we will write here multiple of 2 we have to take. So here 3 we can change. If we will write here 4, so 2 4s are 8 plus 1 9. 9 is a composite numbers because it is divisible by 3. Now next is if we will put here 5. So 2 5s are 10. 10 plus 1 11. 11 is a prime number. So yes, we can find some more numbers of this type. So you will do this activity and send on my personal WhatsApp number. Now even and odd numbers. If a number is divisible by 2, then the number is an even number. And if the number is not divisible by 2, then it is an odd number. Let us see. Do you observe any pattern in the number 2, 4, 6 at the table of 2? You find each of them is a multiple of 2. So these are called even numbers. The rest of the numbers 1, 3, 5, 7, 9 and dash 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 are called odd numbers. IMP underline these lines and then learn. Fill in the blanks, right or wrong. If we want to check the bigger number, whether the number is an odd or even number, we can check observing by units place. See here the units place. Ones place number is 9 and 9 is not a multiple of 2. So 2359 is an odd number. 1, it is also an odd number. Clear? Now if we will take prime number, so 2. So 2 is a prime number, but it is also an even number. So we can say that 2 is the smallest prime number which is even. And odd numbers you can see if we will write all odd and prime numbers. So 3, 5, 7, 11, 13, then 17, then 19, 23. So every prime numbers except 2. All the prime numbers are odd except 2. Only 2 is the smallest. First, 2 is the smallest prime number. 2 is the smallest even prime numbers. And except 2, all prime numbers are odd. These are very important. You will read and all the theory you will keep in your mind. It is the basic knowledge. It is the root of your chapter. Let us start exercise 3.2. What is the sum of any two odd numbers or even numbers? So what is the sum? If we will take odd numbers, suppose that we are taking 3 and 5. When we will add, we will get even number. So when we add two odd numbers, we will get an even number. For example, 3 plus 5 is equal to 8. Now even numbers you will write B. Then you will write, suppose that we are taking even numbers 2 and 4. When we will add two even numbers, that means 2 and 4, we are getting 6. So you will write, when we will add two even numbers, we will get result an even number. For example, in this way you will solve this question. Very easy. The sum of three odd numbers is even. So odd numbers you will take, suppose that we are taking 3, 5, 7. So 3 and 5, 8 and 7, 15. It is an odd number, so it is false. The sum of two odd numbers and one even number is even. So sum of two odd numbers, 3 and 5 we will take. So 8 and even number is 2. So even we are getting even number. 10 is the result. So true. The product only false and true you will write in the CW notebook. No need to write example here for true and false, but I am explaining by taking examples. The product of three odd numbers is odd. So 3 odd numbers, we will take 3, 5 and 7. 3 5s are 15, 15 7s are 105. So false. The product of 3 odd numbers is odd. Yes, true. Product is, we are getting an odd numbers. If an even number is divided by 2, suppose that even number is 6 divided by 2, the quotient is always odd, always. So we will take again next even number, that means 4. So 4 divided by 2, but we are getting an even number. So it always not odd number, sometimes even, sometimes odd. So false. All prime numbers are odd. So prime numbers, 2 is the smallest even prime numbers. So we can't say all prime numbers are odd. False. Prime numbers do not have any factor. No, prime numbers have 2 factors. First 1 and second number itself. So false. Sum of 2 prime numbers is always even. When we add sum, we will take 2 prime numbers. Sum of 2 prime numbers is always even. It's not necessary. When we'll take 2 prime numbers, suppose that 2 and 3, so we are getting odd prime numbers. Or if 3 and 5 we are taking, so we are getting even numbers. So it is not always, sometimes. 2 is the only even prime number. Yes, 2 is the smallest even prime numbers. After each and every even number is divisible by 2 and they are not prime numbers. All even numbers are composite numbers. It's not necessary 2 is prime numbers. So all except 2, if it would be written here except 2, then we can say that the product of 2 even numbers is always even. We will take, for example, 4 2s are 2 and 4 even numbers, and we will take product, we will get even. Next even numbers, if we will take 4 and 6, so again we will get even numbers. So it is true. Now third question, the numbers 13 and 31 are prime numbers. Both these numbers have some same digit 1 and 3. Find such pairs of prime numbers up to 100. Okay, so 13 and 31. So next pair will be, when you will 13, after 14, 15, 16 and 17, and just change the place of digits. So 71 is also prime. So pair you are getting 17 and 71. Next pair, when you after 17, 18, 19, 20, 21. So 19 if you will take prime, 91 is divisible by 13. So in this way, when you will count, you will get this 37, 73, 79 and 97. So you will write prime numbers, pairs of prime numbers up to 100 are 17, 71, semicolon, 37, 73, colon, semicolon, 79 and 97. Now write down separately the prime and composite numbers less than 20. So here prime numbers, here composite numbers, make 2 column, and 1 neither prime nor composite, then 2 prime numbers, then 3 prime numbers, 4 composite. In this way you will form the table. What is the greatest prime numbers between 1 and 10? So the greatest prime number between 1 and 10 is 7, because 7 has only 2 factors. First is 1 and second one is number itself. 9 is divisible by 3. Express the following as the sum of 2 odd primes. So if, what you will do, you will subtract the prime numbers from this number, and if you are getting resulting number is prime, then you will add the number. Suppose that I am explaining here only 44 minus 2. 42 is divisible. 42 is not a odd number, first is, and it is composite numbers. Next number you will subtract 44 minus 3, 41 is odd and prime. So we can write 44 3 plus 41 2 odd prime. So in this way you will write 3 plus 41 2 odd primes. So 2 odd primes. Give in this way you will solve this, this and this. If you are having any query, you can ask me. Give 3 pairs of prime numbers whose difference is 2. Give 3 pairs of prime numbers whose difference is 2. Let us take 2 prime numbers whose difference is 2 are called twin primes. Okay, now we have to take 3 numbers. 3 pairs of prime numbers. So 2 and 3 both are prime, but 3 minus 2 is 1. Difference is not 2. So next pair 3 and 5. 5 minus 3 is 2. So 3, 5, 7. Next pair again you will choose. If you will take 5, 7 and next prime number is 11. But 11 minus 7 is 4. So you will take 11 and 13. In this way you will solve. Which of the following numbers are prime? So 23 and 37 are prime numbers. Write 7 consecutive composite numbers less than 100 so that there is no prime numbers between them. So 1 to 100 numbers you will write first and circle continuously if you are getting consecutive 7 prime numbers. Okay. Now next, express each of the following numbers as the sum of 3 odd primes. So let us start. First, the number is 21. Now see here 21. So first what we will do, 3 odd prime numbers. So we will not subtract here 2 because 2 is an even number. But I am showing you. Clear? So it is mistake because we have to write this number in 3 odd primes number, addition of 3 odd prime numbers. So 21 minus 3, 18, 18 minus 5 is 3, 5 next prime number, so 13. So we are getting 3 odd prime numbers. So we can write 21 as the sum of 3 odd prime numbers, that is 3, 5 and 13. In this way 61 minus 3, 11, minus 3, 8 and 5 is there. Now 58 minus 5, 53. So we can write in 3 odd prime numbers, addition of 3 odd prime numbers. So 3, 5, 53. In this way you will solve B and C. The next question is write 5 pairs of prime numbers less than 20 whose sum is divisible by 5. So we will write addition of 2 prime numbers in such a way that result will be divisible by 5. So let us start. Children, in 11th question you will make correction. There is written less than 20. We have to calculate or we have to find the prime numbers in such a way result will be less than 20 and divisible by 5. But there is written less than, but you will write less than or equal. Because if we will not write equal to 20, less than or equal to 20, then we will not get answer. Clear? So all prime numbers less than 20 I have written here. So when we will add 2 plus 3, 5, 5 is divisible by 5. The next is 2 plus 13, 15. 15 is divisible by 5. Now next is 3 with 3 and 7. 10. 10 is divisible by 5. Next is with 3. We can write 17. 17 and 3. So divisible by 20. 20 is divisible by. So 20 equal to number we are getting. So we will change in the question number 11. Now 5 with 5. What number we can write? No. Now 7 plus 13. So we can write answer we will get 20 and 20 is divisible by 5. So we will write here in this way. 3 plus 7 equal to 10. 10 is divisible by 5. Then 2 plus 13. 2 plus 3. 3 plus 17. 7 plus 13. And one more pair you will find. Okay. Now fill in the blanks. A number which has only 2 factors is called a prime number. A number which has more than 2 factors is called composite number. One is neither prime nor composite. The smallest prime number is 2. The smallest composite number is 3 is prime Then 4 is composite. So smallest composite number is 4. The smallest even number is 2. And if asking the smallest even prime number is also 2. And in this way 3.2 here completed. Now complete your notebook.